From grade 11, the standard form for a parabola or a quadratic function, the standard form changes from ax squared plus q to ax squared plus bx plus c. When they ask you for the standard form, you have to give it in the form x squared x constant, always. They can also ask you to leave the equation of the function in the form of completing of squares. So that means you have y is equals to a bracket x minus p bracket squared plus q. The p value stands on its own. So if you have a p value that is positive, if you have a positive value for p, the graph moves to the right. And if you have a p value that is negative, the graph moves to the left. But be careful. In the equation, if you have x minus p, the graph moves to the right. If you have x plus p, the graph moves to the left. And this is because the p value is the number that makes the bracket 0. Okay? The value that makes x minus p 0 is the value that p is. So in a sense, you can say that you have a x minus in a bracket p squared plus q. The p value works on its own, separate from the sign in front of it. The formula is x minus. So if you have x minus 5, your p value is positive 5 because it makes the bracket 0. I hope this makes sense. To find the equation, you need to have the turning point and one other coordinate, your y-intercept, and another coordinate, or two x-intercepts and a third coordinate. So, if you have your turning point and one other coordinate, you can use the formula of a is equals to x minus p squared plus q, where p is the x of your turning point and q is the y of your turning point. So if they give you a turning point of 2 and 5, you have x minus 2 plus 5. To find your a value, you substitute the third coordinate they give you and solve the equation that way. If you use this method, make sure that they don't ask you to write your final answer in the standard form. If they do not ask you to write it in standard form, you can leave it as it is. Otherwise, you have to write it as the standard form of ax squared plus bx plus c. If they give you your two x-intercepts and another coordinate, you work with y is equals to a bracket x minus root 1 and x minus root 2. So root 1 and root 2 will be the x-intercepts that you have. Then you simplify the brackets and you have a and a long bracket. You can multiply everything out, but I would not advise that. You can leave it as x minus 2 and x minus 5 and substitute your extra coordinates to make your life easier. To draw the graph, you have 5 steps that you need. You have to show this to make sure you have everything that is necessary to draw the graph. First thing you need is you have to make sure of the shape. If you have an a bigger than 0 or positive a value, then you have a smiley face. If you have a smaller than 0 or negative, you have a sad face. for the shape of your graph. Then you have to find your turning point of the function, which you can find using either completing of squares to have a p and q value, or if they give it to you in standard form, you can use the short formula negative b over 2a to get your x coordinate of the turning point. Now, when you have your x coordinate, you substitute it into the formula they give you to find the y coordinate of your turning point. Once you have that, you plot it on your graph and you go on to check. Do you have a y-intercept? For your y-intercept, you substitute x equals to 0 and you plot the y-intercept on your Cartesian plane. After that, you have to go and make sure, do you have a graph that will have two x-intercepts, or will it not have two x-intercepts? The only time that you will not have your x-intercepts is if your turning point is above your x-axis. So first make sure where your turning point is before you start to struggle to find an x-intercept that may not exist or that may not be necessary. If the equation is too tricky, you may use the quadratic formula to solve it. So negative b plus minus square root b squared minus 4ac over 2a. You may use that to find your x-intercept. And finally, you draw the graph.